guys, today we're going to be learning about stream dynamics, which is essentially how a stream changes over its lifespan, and some of the erosional and depositional forces at work within a stream, which we've been talking about in the classroom. So let's first start with a definition of a word, which I think is pretty important. It's called a watershed. A watershed is an area of land that is drained by a particular river or a stream. And that's kind of a broad definition because we're not defining how big of a stream or how big of a river we're talking about. So it can be anything from really, really tiny little streams to really, really big rivers like maybe the Mississippi River. Now on the screen, you see a picture of what's called the Hudson River Drainage Basin or the Hudson River Watershed. And that's a big area on the eastern side of New York State that includes the whole entire Hudson River, which starts up in the Adirondacks and winds its way down all the way to New York City. And it gets pretty big by the end, obviously, because all of these tributaries, like the Mohawk River and some of these other feeder streams, will feed into the Hudson River and drain out here. Now, the cool thing is, any rain that might fall or precipitation that might fall in this area will exit eventually out through the Hudson River at New York City. If rain falls in Syracuse, it's not going to go into the Hudson River. It's going to go to a different watershed. Now, what I'd like you to do is I'd like you to sketch a watershed, and I'll show you that right here.
Here's my river, okay, my main branch of my river. It has a lot of tributaries. Tributaries are feeder streams that come into it, okay, and they kind of look like branches on a tree. So just draw a bunch of those. And basically all of this area that is around the river and all those feeder streams is known as the watershed. So if I were to sketch a border to it, I'm going to draw that with this red line here. That would be this area around the river, which means that if it rains anywhere inside of this area, it's going to go into one of those feeder streams and then into the main river and then out over here, out of the river over here. Okay, maybe the exit of that river is the ocean, okay, down here. That's possible. Or maybe it's a big lake, or maybe it's an even bigger river. So watersheds can be defined as this area around it. Now, if I were to kind of sketch that area or shade in that area, essentially it would be all of this entire thing, okay? Anywhere inside of there is the watershed. Okay, so go ahead and sketch that. Now, the other thing to take note of is the fact that there might be another stream or another river that's over here, okay? And it might have its own tributaries like this. This red line that separates these two actually connects them. So if it rains on, let's say, this side, there would be a hill right here. There's a hill at the peak of the hill, and the rain might go that way to the north. Or if it rains on this side of the hill, it would go this way to the south and feed into this other stream, this second river that I drew.
Okay, so these are all the watersheds across the United States, the larger ones. So we have the Atlantic coast, you can see here. We have this orange one, which is the Mississippi River itself. But the interesting thing is the Mississippi River also includes other big rivers like the Missouri and the Ohio, which are over here. So the Mississippi River drainage basin is really, really large, and I'm going to show you that in a second. This area right in here, this kind of darker greenish blue color, is our watershed of the Great Lakes. And so all the water that's falling in here is going to go out through the Great Lakes system, out the St. Lawrence River, out into the Atlantic Ocean. We're going to be doing a lab with watersheds in the classroom, and so you'll get to see this a little bit more in detail. This shows you a little bit closer look at that. You can see Syracuse is like right around here, and so our water drains out to Lake Ontario and then up the St. Lawrence up this way. Now, this I think is a really neat picture, and we'll look at this a little bit more in the classroom, but you can see the Mississippi River drainage system is this big pink blob here. All of these little tributaries all feed into the Mississippi River, which gets really, really big and large by the end, and then exits out the Mississippi River Delta, which is down here. Okay, this is the Colorado River, which is on the opposite side of the Rocky Mountains, and so you can see that drainage system is pretty big too. But again, the Mississippi makes up most of the United States. Okay, now just to kind of talk a little bit about stream evolution, what I'm talking about is the way the stream changes over its lifespan. So if you start up in the mountains, rivers and streams tend to be very narrow and straight. They have a really steep valley. We have a nice V-shaped valley, which we'll be looking at a little bit later on as well, but nice V-shape where the river is cutting into the bedrock and making this nice straight channel. Now, as it moves downhill, it eventually will get into terrain that is not as steep, and therefore it starts to slow down. The river slows down and widens out and kind of meanders back and forth. And so you have this broader valley, and this area is called the floodplain, which we'll define later. And you have these kind of low hills next to that. Over time, this will widen out even more, and eventually this river will get down to the really low elevation and close to the ocean, and it'll really spread out and slow down, carrying lots of water, big wide river, and meanders back and forth like that. And so we have this evolution over its lifespan as it heads from the hills all the way down to the plains, down to the ocean, where it will exit out into the ocean. So just be aware of how a stream changes over its lifetime. Now I mentioned, so it kind of shows the big picture right here, just to show you all that as it heads downhill. You'll see a lot more meandering as it gets down to the end of its lifespan. The end of a river is called a delta. All of that water is going to be carrying a lot of sediment, and it'll deposit out here as it heads into a big body of water like a lake or the ocean. Okay. Now, I mentioned this word before. A floodplain is a great vocab word that you should probably write down. A floodplain is an area that is covered by floodwater. Now, you can see the area next to the river here is pretty flat, and so if this overflowed its banks, its natural levees, those are the banks of the stream, it's going to flood into this area. This is a risky area to build. Obviously, you wouldn't want to necessarily build in the floodplain because you have the potential for the river to overflow and flood whatever residence you might have. But it's a really great place for farming because you have some really good soil in this area. All right, this slide here is an important one. A lot of really big things come from understanding this basic information that's on this slide. So I would write a bunch of this down, especially that red line there. Stream velocity and erosion. There's two forces at work in a river, in a stream. There's the forces of erosion, and there's the forces of deposition. And they're essentially opposing, they're opposite of each other.
By the power of Grayskull! Together we defend Castle Grayskull from the evil forces of Skeletor.
Now we'll just talk about erosion first. If you have a really fast-moving stream, then you're going to have a lot of erosion. And you can see there's a nice direct relationship there shown by that statement. Increase the velocity, increase the rate of erosion, which goes along with the reference table page 6 that we've been looking at over the last couple days. Now, what would make the stream velocity increase? Well, there's a couple of things here. If you have a steeper slope, as it says here, then the river's going to go faster. Or if you have a lot more water in the stream, then it's going to be going faster. Okay, so really a couple of things. Obviously, a lot more precipitation or snow melt will lead to a lot more water in the stream, a lot more discharge, we call that, and therefore it's going to go faster. And as a result of going faster, you're going to have a lot more erosion taking place. And that's important because that leads into some other discussions we're going to look at here. Now, in a straight stream, the river or the stream is always going fastest in the middle. And so you can kind of see that here. The maximum velocity is right in the middle, away from the edges, the banks, away from any forces that are going to slow it down. You're not going to have as much friction, right in the middle of the stream and just below the surface technically. Okay, but not all rivers are straight. And so it gets a little bit complicated to determine where there's a lot of erosion taking place. All right, and remember, erosion is going to carry away sediment. So it's going to carve away. It's going to be really deep in the middle of the stream too. So what about when a river is not straight? What happens when it winds back and forth or meanders back and forth? Well, now we got some crazy stuff going on, and I want to kind of look at that, but I want to show you this picture here. This picture here shows a meandering river or meandering stream, and you see a bunch of things labeled on this, and I'm going to be drawing this in a second. But just take a look at this blue arrow right here. Indicates the fastest part of the stream. The fastest part of the stream is on the outside of a curve. And it's kind of like a baseball bat, right? If you swing a baseball bat, the outside of the bat is going much faster than your hands are.
First base side of the pitching rubber.
That's driven out to right center field. That's got a chance. Goal!
And so the outside of this curve is where it's going fastest. The higher the velocity, remember, the more erosion is taking place.
All right, guys, I'd like you to sketch a stream right into your notes, a meandering river or meandering stream. Probably not in red. Let's use blue. Okay, so meandering back and forth like that. And I'm going to make the other side, the other bank of the river there. It doesn't matter which way this is flowing. What I want you to recognize is there's obviously different sides of this river. Those opposing forces of deposition and erosion are at work in this river. So if I were to identify where this river is going fast, I'm going to do this with a red line. Remember, it's always fastest down the middle of the straight part of the stream, and then it's fastest on the outside of the bend, way out there, taking the long path. And then it's always fastest on the outside of the bend over here. And then it's fast down the middle, and then fast on the outside, and then back down the middle again. Okay, so if that red line were to define the fastest part of the stream, well, that makes it really easy to determine where the erosion is taking place and where the deposition is taking place. And remember, the erosion is where it's always going fastest. So if I were to label that, I'm going to label erosion with a yellow. Okay, so erosion is over here. I'm just going to write a capital E for erosion. That's the fast side of the stream, the outside of the curve. And erosion is down here, okay, on the outside of the curve. And erosion is right there on the outside of that curve, which you saw in the video. Deposition, it's where it's going slower. So that would be on the inside of the curve. So there's the deposition side, there's the deposition side here, and there's the deposition side for that part of the river. Okay, so you need to be able to identify on a meandering river, where is it going fastest, where is it going slowest, and therefore where is erosion happening and where is deposition happening.
Now, the next part of this is interpreting what does this river look like underneath the surface? What does the bottom of this river look like? And I'm going to show you that right here.
One last thing to identify in regards to a meandering stream is the depth of the stream at different places along the river. Now, I could ask the question, of all of these letters, where is erosion happening? Where is deposition happening? And you would be able to determine that A and D represent the inside curves, and therefore that would be where the deposition is happening. And B and C are the outside curves, therefore that's where erosion is happening. But the further thing you got to look at is, what if we drew a profile from A to B across that river? And remember, a profile is a side view. So if I were to draw here's the top of the river. Okay, that's the water surface. Here's A right here. Okay, and that's B right there. What does it look like underneath of the river, the banks of the river and the bottom of the river? Well, it would always be deeper where there's more scouring and eating away at the bottom of the river, where the stream is going fastest. And that would be where the erosion is taking place. And we just identified that B is the erosion side. So it's going to be deeper on the erosion side and shallower on the deposition side. So it's going to have this kind of a shape to it, where A is shallow and B is deep. And the fastest part of the stream would be over here. This area right on the B side is called the cut bank. The river is cutting into the bank, and we saw that in the video of my stream table. So if I were to kind of draw what it looked like up above, if this were the land, up above here, it's cutting into that bank. It's really steep there. Whereas on this other side, where A is located, it's kind of more flat. And this is called a point bar, where it's kind of flat and sandy. All right, so you have the deeper side and the shallower side based upon whether it's erosion or deposition. Now, if I were to draw a profile of C and D, so I'll draw a line across here, and I were to draw that profile, here's my stream surface. Here is C, and here is D. And now what we need to do is draw what it looks like underneath. And remember, C is the outside curve this time, and therefore it's deeper over there. So I'm going to draw it deeper over here and shallower over on the D side. So it's kind of the opposite of A and B. All right. So be able to identify not only erosional and depositional sides of a river in a meandering stream, but also what does it look like from a profile view.
You're most likely going to see questions regarding the idea of erosion versus deposition sides of meandering rivers. I'll give you an example of one. It says to draw an X on the diagram where erosion is taking place. And remember, that's always on the outside of the curve. So that would be over here. Okay, you could draw it over here. Or on this curve, it would be on the outside over here between A and B. Okay, so just be aware of questions that you might be asked. Here's another one. Which two locations have the greatest stream velocities? Well, that would be on the outside of the curve where the erosion is taking place. So if you're following this along, the outside curve is A and the outside curve is D. So the answer would be number 4. Okay, so just to give you guys some examples of them. All right, so again, we'll be working with this stuff in the classroom. We'll be playing around with the stream table, which we saw. And if you have any questions about this, just let me know, okay?